So what I'm going to do is I'm going to do a presentation with a set of slides. And just to say, this is a very, very broad title. And when you're asked to do this 2 months ahead and can't quite think what to say, the temptation is to come up with a very broad title. And then 2 days before, you need to focus down on what you're actually going to do. Just to say, it is great to be back at CMU, even virtually, to give this talk. So what I'm going to do very quickly, the last IPCC report that touched on energy was the special report on global warming of 1.5 degrees. And I'm going to run through the results of that very quickly. And then I'm going to pick up what you might call hot topics in the energy area that will be the subject of the next IPCC report, which is in preparation. I'm also going to just say a few words about just transition. I was listening, fascinated to what Mayor Peduto and Grant Irvin were saying there. And finally, just a couple of personal reflections on US re-engagement with the Paris Agreement. So that's what I'm planning to do very quickly. So back in 2015, when the Paris Agreement was signed, all the governments decided that they didn't actually know what 1.5 degrees warming actually meant. They had a fairly good understanding of 2 degrees. And so they invited IPCC to produce a special report on the impacts of global warming of 1.5 degrees, and secondly, related greenhouse gas emission pathways. And just to say, myself and my fellow co-chairs had only been elected a few months before, and we were sitting there in Paris saying, please don't ask us to do that. But the question was asked to us, and we rose to the considerable challenge of producing this report in quite a short period of time. So to cut straight through to the climate mitigation and the energy relevant part of it, one of the things the report did was look at the kind of global pathways of greenhouse gases that were compatible with global warming of 1.5 degrees. And the authors found about 90 scenarios out there in the literature that were compatible with 1.5 degrees warming. And these are the kind of sort of the blue band on the left-hand side of this slide. And just to say, this outcome is very much a question of being down to chemistry and physics. There isn't so much social science and economics on this, but the broad picture is very much physical science driven. If that's your level of ambition, that's what you need to do. And the big messages we pulled out of that were the message that global emissions of carbon dioxide would need to reach net zero by about 2050. And that even by 2030, and then we're talking about a 2018 start, global emissions of carbon dioxide would need to fall by ballpark figure 45% by 2030, an incredibly ambitious level of reduction. And emissions of other gases like methane, black carbon, nitrous oxide would also need to fall, but they would never reach net zero like carbon dioxide. And this net zero concept has obviously really caught on as many countries have now set out net zero ambitions for mid-century. One of the other things that we did in the report was to say, well, there's more than one pathway up the mountain, as it were. There are actually, even though 1.5 degrees is ambitious, there are some choices about the strategies that you could conceivably employ to get there. And so we picked out sort of 4 illustrative pathways for carbon dioxide emissions, all of which are more or less compatible with 1.5 degrees warming, but have very different characteristics. And in each of these diagrams, the solid blue line shows net carbon dioxide emissions, which in all cases crosses zero at about 2050. The grey area refers to emissions from fossil fuels and industry. The orange part is emissions or sinks from agriculture, forestry, and land use, which can be positive or negative, and depending on how you're using the land. And perhaps more controversially, the yellow part of it is associated with bioenergy combined with carbon capture and storage, a subject on which I will bow to Ed Rubin in terms of detailed knowledge. But what this was showing, there was a very basic choice in the system. if you made very rapid progress, and this is extraordinarily rapid process in dropping fossil fuel emissions of carbon dioxide, you could do without these negative emission technologies later in the 21st century. But if you delayed even by 10 years or so, it meant that you would have to rely heavily on bioenergy with carbon capture and storage and or afforestation to actually keep within the 1.5 degrees warming limit. And just to do a little bit of calibration here on that pathway one, as a result of the COVID crisis, global emissions of carbon dioxide have fallen by between 5 and 7%, depending on who makes the estimates. This pathway involves declines in carbon dioxide that are 7% per year cumulatively over about 20 years. And this is really an extraordinary, it's like piling COVID upon COVID for 20 years, because in the short term, you have the capital stock you have, and most of this would need to happen as a result of behavioral change. So we produced a pile of messages to go with these scenarios. On the first one, limiting warming to 1.5 degrees would require 3 carefully chosen sets of words: rapid, far-reaching, and unprecedented changes in all systems. And some of the examples are given below. It would cover technology, it covers behavioral change. It needs a massive scaling up of investment in low carbon energy and energy efficiency by 2050. Renewables, or alternatively nuclear, would need to supply most of electricity demand globally by 2050. And coal use would need to be, for electricity generation, would need to decline on the way to zero by 2050 in any of these scenarios. Worthwhile saying that oil, and especially gas, can persist a bit longer in the system. And in some of the scenarios, gas use actually rises by 2050. And obviously, deep cuts in transport, buildings, and patterns of land use and urban planning would also need to change. Now, the other element that was indispensable in these scenarios was carbon dioxide removal from the atmosphere. And every pathway that limits global warming to 1.5 degrees involves some kind of carbon dioxide removal. And it serves 2 purposes. Sometimes it compensates for emissions in difficult sectors like energy intensive industry or aviation. But for other uses, it's actually to extract carbon dioxide from the air so that we actually see the concentrations of carbon dioxide reducing overall. And there are many methods for removing carbon dioxide, not all of which are captured in the models whose runs I showed you in the previous diagram. So forest management has a big part of it. Not only planting trees, but leaving existing trees to grow would be part of it. Carbon capture and storage, which could be combined, of course, with bioenergy. And this is obviously the net impact of that system. You grow trees, you burn the wood in power stations, capture the carbon, bury it in geological formations. And this is a system that has a net removal of carbon dioxide from the atmosphere. And there is a very growing increase in so-called nature-based solutions, which include soil and livestock management, restoring peatlands, various other land management practices could all play a big factor. But as I'll get on to, some of these nature-based solutions and anything that uses land have potential implications for food security if land is converted, water security, ecosystem services, and biodiversity. Now, is what we're doing enough at the moment? And the actual answer there is an absolutely emphatic no. What this slide, which is produced, updated on an annual basis by the United Nations Environment Programme, shows is that the current pledges made by governments at or after the Paris Agreement are simply not enough to take you to the kind of emission reductions that are needed. Even in the most optimistic case, which is cryptically called the unconditional NDC scenario, then it is not possible to keep global warming between 1.5 degrees or even 2 degrees during the 21st century. We're more likely to be on a path to 3 degrees warming. So every country really needs to step up its ambition if the targets of the Paris Agreement, which is to limit warming to well below 2 degrees and pursue efforts towards 1.5, are actually going to be achieved. Now, that was kind of the output of our 1.5 degrees report, and we are currently very busy producing the next reports for IPCC, which will be a bit delayed as a result of COVID, but should be coming out within the next year or so. And just to say, I can't talk about these reports because we're not supposed to talk about these preliminary results, but just to flag that Paulina Jaramillo from Engineering and Public Policy is one of the authors on this report that we're working on at the moment. So what I'll show is I'll just show a couple of slides that kind of calibrate where we are and give some of the, the major real world developments at the global level. Now, this first one, which is from the International Energy Agency, is a kind of sobering picture about the picture on world primary energy demand according to the type of fuel that's used. So, for example, it's very clear, 80% of energy use globally is still associated with fossil fuels, and oil is the single biggest energy source. In spite of all the talk about wind and solar energy, that's that little blue slice there, that blue sliver at the top. It's not very much so far. Worthwhile saying that the accountancy that the International Energy Agency uses to measure primary energy effectively underestimates that. I would say it's worth about 3 times more than that if you use a different kind of primary energy accounting convention, but it's still a very small part of the picture. However, this slide is from the International Renewable Energy Agency. We can see there have been extraordinary declines in the cost of renewable energy over the last decade or so, and not just theoretical calculations, but numbers that are realized in real auctions on power purchase agreements, which are the orange lines there. The grey bands show the range globally of conventional electricity coming from fossil fuels. And you can see that for solar photovoltaic, onshore wind, and even offshore wind, the costs are now well within and towards the bottom end of the band of fossil fuel electricity. And in many cases, in fact, for example, for solar photovoltaics, for onshore wind, the costs have dropped below it. This might be the cheapest way of actually producing electricity. So big changes in energy systems as a result of renewables. And I expect that renewables proportion is going to go up very rapidly in the future. Worthwhile now turning to the fossil fuel side, and a couple of colleagues from London, Christophe Maglade and Paul Ekins, and Christophe Maglade is now at the International Energy Agency, produced a paper in 2015 which talked about so-called unburnable oil. And that's the top left-hand diagram showing what the picture might be of oil production out to 2050. And this is more a 2 degrees scenario than 1.5 degrees. But a very clear message that a lot of fossil fuel reserves would need to stay in the ground if we were going to limit global warming to the kind of levels hypothesized in the Paris Agreement. Another piece of work done by a colleague, David McCollum, who's actually now at EPRI out in Palo Alto, looked at the investment costs associated with different energy systems under different scenarios. So it's broken down by the extraction and conversion of fossil fuels, other kinds of high carbon activities in the energy sector, low carbon investment on the grey side, and demand side investments. The top right picture shows what would be needed if governments fulfill all the pledges they've made under the Paris Agreement. The bottom left shows what would need to happen if we kept global warming to well below 2 degrees, say about 1.8, I think was what they assumed. And at the bottom right, what would happen if global warming was limited to 1.5 degrees? And there's a very strong picture that obviously investment in the energy sector would need to go up the more climate ambition you have. But there's also a very significant change in the pattern of investment, with huge increases in investment in renewable energy, which is the low carbon side, and energy efficiency in the ambitious scenarios. And what would otherwise have been an increase investment in fossil fuels under a Paris Pledges scenario becomes a decline in investment in fossil fuels in the well below 2 and 1.5 degrees scenarios. Well worth emphasizing that investment in fossil fuels does not go to zero. even in a 1.5-degree scenario, because current fields decline and these do need compensated for in the future. And I am reminded, this will be very familiar in Pennsylvania, the very big impact that shale has had on the picture. It's not only changed the US picture, but it has had knock-on effects in international markets, as shale gas here in the US has driven out coal from power stations, spilled it onto international markets, and reduced the prices. So there has been big international effects from this side as well. I'm speeding my way through this, but I just wanted to flag that the working group that I'm co-chair of managed the second IPCC special report on climate change and land. And just to say, I consider myself pretty much an expert on energy, but it was only when I started to look at land issues, I was truly humbled by the complexity of some of the issues there, both in terms of measuring emissions and some of the socioeconomic issues associated with change. So what came out of this report was again to address this issue of bioenergy and bioenergy with carbon capture and storage. And there was quite a strong message in this report about the degree to which the deployment of bioenergy at the scale envisaged of some of these scenarios has real negative implications for food security and especially for ecosystem services and biodiversity. But a very strong point that doesn't mean bioenergy is bad. And we really want to emphasize that. If you do best practice, if you produce bioenergy in marginal lands, abandoned croplands, and manage it sustainably, then the impacts can be managed. And there can actually be benefits from the deployment of bioenergy that go beyond simply climate change mitigation. So that's the reason there is this thought that you can solve this problem by planting more trees. And just to say, many people pledging net zero have said they will buy credits, and some of these credits might be associated with tree planting. But we do need to remember that trees get planted on somebody's land, and somebody has a title and an ownership over it. So we need to think about that quite carefully. Last thing I want to flag for this report from IPCC is that for the very first time in IPCC, we're actually thinking about social issues on the demand side and giving a much greater emphasis to it. So, for example, we have a chapter that is looking at all of the topics listed here, which governments said they wanted: sustainable consumption and production, culture, social norms, practices, and behavioral changes, which will be a true challenge to get approval from many countries on, circular economy, social acceptability of supply and demand solutions. So the social side of a transition is also beginning to get an increasing amount of attention. Which brings me to the third topic I was going to briefly cover. As well as doing the IPCC job, I'm doing something pretty much non-academic at the moment. I have been chairing in Scotland, and some of you will be able to tell from my strange accent that I'm not, although you definitely know I'm not American, I'm also not English. I'm actually from Scotland originally. And I've been chairing a Just Transition Commission for the Scottish Government, which coincidentally, we launched our report just at lunchtime in the UK. And I've spent my afternoon talking to television stations about the results of this report. And just to say, we've called it a national mission for a fairer, greener Scotland. And I have to say, I just find extraordinary how many resonances there are with the remarks that Mayor Peduto and Grant Irvin that were being made earlier. A big emphasis on the Scotland's particular situation is we got out of coal about 5 years ago. And the last coal power station site is now about to be used to manufacture high-speed trains, which is a nice transition to make. The two of the challenges for Scotland are, first of all, a lot of the economy in part of the country is dependent on offshore oil and gas from a regime that is mature and is now going into decline. And one of the big challenges we have got there is transferring the skills of that sector into the new energy area, for example, from offshore oil and gas production to offshore renewables, and offshore wind has been a big fixture. And in the longer term, using some of the skills of industry to move into hydrogen and carbon capture and storage. So the Upper Ohio being the hydrogen valley is something that really very much echoes with us. The second thing that we have emphasized, because of that history of getting out of coal, is that we need to look at the demand side of the energy as well. And how we do energy efficiency is very important. Now, anybody who's stayed in Scotland in winter will know that these are not the best weather-proofed homes. And we have a big advantage, a triple kind of win from making big investments in improving the energy efficiency of housing. It will reduce carbon dioxide emissions. It means people on low incomes will have warmer homes. And it will also provide a much greater degree of employment as we go into the retrofitting of homes. It's a triple win and one we've emphasized. And I'm particularly keen to hear the remarks from Paula Glaver later on justice in the energy transition, because it's been a very big part of it for us. Now, I'm running out of time, so let me talk just a few very personal remarks about the US and global climate policy and how it actually fits in. Just to say, because I'm in IPCC, I'm not supposed to comment on the work of individual governments. So let me just not put anything on the slide and just say it verbally. And just to say, the US hasn't been absent. IPCC had a pavilion at the last International Climate Conference in Madrid, which took place at the end of 2019. And opposite us was the non-official US pavilion, which had a wall-sized picture of downtown Pittsburgh taken from Mount Washington. So you were still there, absolutely, in the international picture. But it is actually great to have, I think, the US back. The US is still the second biggest emitter of greenhouse gas emissions globally. And to have the US back in the climate regime is really, really important. I think a second advantage, I've been through several changes of administration in IPCC processes. And frankly, you don't always notice very much difference, as you go from one to another. But we noticed it with the change in 2016. Partly because I think the State Department officials who led for the US were perhaps a bit disconnected from the people on the bridge, as it were. There was a very obvious lack of confidence and ability to participate in the meetings. And we are really, really looking forward to the US playing a big role in that respect again, because I have to say I value the quality of US interventions. They can sometimes be uncomfortable, but they end up giving us a better product at the end of the day. And the very final thing I'm looking for is greater scientific participation in IPCC from the US. We didn't publicize this very much, but when we had our last call for authors, from the US, it was down by about 50% compared with previous IPCC cycles. And that was spread evenly across the university system and the national labs, which are also a major source of input. So I hope when IPCC next selects its authors from the nominations made by governments, it can actually boast about a big increase in participation from the US, because I personally think it would be a very good thing for IPCC, and it would be great if scientists from Carnegie Mellon were also part of that process. So I will call a halt there. That's been an express ride through my slides, but I hope that's been of some interest to people.
Jim, it's fantastic. We have a number of questions that are coming in, and so I will ask you a couple of these. We will hold to time, so if there are any that we get to and you have a minute to see them, you can actually reply to them directly as well. So one of the questions that's come in is how much of the dominance of coal and oil as opposed to renewables is due to problems with shortage?
I would say it was not
storage, not storage.
Yeah. But I'm reading the questions well, Anna. I would have covered it. Yeah. Okay. So well, frankly, I don't think very much. I mean, I think in most electricity systems, you could take about, say, 25% wind based without much adaptation to the system. You need to manage it in a very different way. When you get greater levels of connection, so you do need to invest in more backup storage. In Europe, greater interconnection between different parts of Europe will help us. And also demand side solutions. For example, integration between electric vehicles on the grid could become important. So it's not a showstopper. in my view. And I look at another Celtic country like Ireland, which has a very limited connection to the outside world in terms of electricity, and they have absorbed incredible amounts of wind onto their electricity system. I think it's very doable. It's a technical problem. It's not a showstopper.
Okay. And then another question, I think we have time for this one more, which is how energy efficient is BECCS after accounting for energy inputs from farming, processing, carbon capture, and storage?
Yeah, and this is a question for my good colleague Ed Rubin. Actually, he's much better placed. He's done all the papers on this one. So I don't have a number on it, but plainly there is a big loss of energy from the carbon capture process, and whether that makes sense depends on lots of things, like what value you put on carbon in terms of a dollar price per ton of carbon dioxide. But just to say, BECCS does not really exist at the moment. All the bits of the BECCS chain, it's a chain from the field to the power station, to the transport system, to the storage. And all the bits of that chain have been done, but nobody has really at scale put it all together in one place. And I think most of the obstacles around that are around the business models that are available, the policy framework, and actually what the value that would be attached to carbon. There's absolutely a loss of energy efficiency from BECCS.
And we actually have time for just one more, which is, you mentioned very briefly the need for nuclear energy to provide a large percentage of low carbon energy, but it was not obvious where it shows up in the graphics of the various scenarios. So could you elaborate on the assumptions regarding the role of nuclear power in the IPCC scenarios?
Yeah, this is IPCC's most delicate topic, because anything we say about nuclear power of whatever stripe will be shot down by one government or another. So our standard line is that it's up to individual governments, will make their own individual choices, etc. I mean, there is absolutely nuclear power in these scenarios. And in the 1.5 degree scenarios, the use of nuclear power absolutely does go up, but not as much as renewable energy goes up. So it's an increasing part of the picture. I think what we have seen over the last few decades is that nuclear power globally has stayed pretty stable, but that is the cancelling out of two opposing trends. We've actually seen a lot more nuclear power in East Asia, where Japan, Taiwan, China, but there's been declines in Europe especially, and also North America. We've seen it going down as older nuclear stations have closed. And I think it would need actually quite a lot of political will to change that direction. And certain countries in Europe, like Germany, there is no prospect on a generational scale of them ever going back to it, I think.